So we are going to do congruency in right triangles today, and we're going to use the HL theorem. Before we get into the HL theorem, we need to know the parts of a right triangle. Okay? Across, opposite of the right angle is called the hypotenuse. Your hypotenuse is opposite of the right angle. It's the longest side of a right triangle. Longest side, opposite of the right angle. The other two sides that form the right angle are called the legs. The legs are two sides that form the right angle. They create the right angle. I guess you would say that the legs are perpendicular to each other since they make a right angle. All right, hypotenuse, opposite of the right angle. The other two guys, the legs. The HL theorem is abbreviated for the Hypotenuse Leg Theorem, which states, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the two triangles are congruent. HL, you need to have congruent hypotenuse, and you have to have a congruent leg. HL theorem. Okay? This only works in right triangles because the hypotenuse is only found in right triangles. There are three conditions you must meet when you're using the HL theorem. These three things need to be listed in your two-column proofs. First thing, you have to have right triangles. If you don't have right triangles, then you can't use the HL theorem. So you need to tell me that they're right triangles. Second thing, you have to have congruent hypotenuse. And then the third one, you have to make sure you have listed in there that the legs are congruent. What? That the hypotenuse are congruent? That if you have two right triangles, this hypotenuse is congruent to that hypotenuse. And then the legs, you'd have to have corresponding legs congruent. Okay, so HL, congruent hypotenuse, congruent leg, you have to tell me they're right triangles. Those three things are listed there before number one. And we're going to go right to number one to start. So, given angle ABC and angle DCB are right angles, and AC is congruent to DB, we want to prove that the two triangles are congruent. What's your first step in a proof? The given. Good. Copy your given down. I have to be able to understand it. No. Just like some of you like to draw a picture of a line when you should write the word line. Don't do that. No lines. All right, after you write the given, then what do? Mark your picture. Good. ABC and DCB are right angles. They marked that for us. And then AC is congruent to DB. So this whole segment here, AC, is congruent to this whole segment here, DB. If you want to, you could pull the two triangles apart and mark them too. You don't like the overlappingness of them. We're trying to prove that triangle ABC, this one on the bottom, is congruent to DCB, this top left corner one. You have 5 ways to prove triangles congruent. Side, 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 angle, 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 side, and now the HL theorem. So you can use any of those. You just have to figure out which one works best with what you're given. What do you think? HL? Why would you say that? Because you're learning about it? 2 of the 3 things are already figured out? Like what? 2? Okay, and what's the third thing? Good. One of the legs of the one triangle has to be congruent to the corresponding leg of the other triangle. So basically, you're trying to tell me I'm trying to find 2 more sides that are congruent. Okay. That's within the same triangle. If 2 sides of one triangle than the two angles in that same triangle. Does that make sense? Okay. Yeah, a couple of you said it. BC. Both triangles use that left side, BC. Since they both use the same segment, wouldn't it be congruent to itself? Okay. So step 2, BC is congruent to BC by what? The reflexive property. Okay, so we need to meet 3 conditions. Here's the legs. Here's the hypotenuse. What's the third condition that we have to meet? Right angles? Right triangles. Good. I need to state that they're right triangles. Have we said yet in the proof that the triangles are right triangles? No, but are they? Why are the triangles right triangles? Because they have a right angle. Excellent. So for step 3, triangle ABC and triangle DCB are right triangles. Since they have a right angle, they're right triangles. So we're going to write by the definition of a right triangle. Nope, it only tells you that you have right angles. You have to tell me that the triangles are right triangles. Without the picture, how would you know? So you have to put it down in words. Now that we have all 3 conditions met, then you can tell me that triangle ABC is congruent to triangle DCB by the HL theorem. Three things. Right triangles, hypotenuse are congruent, legs are congruent. What do you mean? Like which one? Then no. It's the only way you can prove them congruent. All right. Number 2. I mean, sometimes you can, Sarah. There might be multiple ways, but on that one, that's the only one I could use. All right. So given to us here, CD is congruent to EA. AD is the perpendicular bisector of CD. So after we write the given, then what do we have to do? Mark the picture. CD is congruent to EA. AD is the perpendicular bisector of CE. Bless you. AD is perpendicular to CE. What's it mean if these segments are perpendicular? They make right angles. That's already marked. AD is the bisector of CE. If AD is bisecting CE, what is it doing to it? Yeah, cutting it into 2 congruent parts. Which 2 parts are going to be congruent then? Good, CB and EB. Because AD is the bisector. Okay, we're supposed to prove that those 2 triangles are congruent. Yeah, I could say that those are vertical angles, but since having them both with 90s in there does not mean they're also congruent. Yeah, you could do it either way. What do you think? Do we have enough to prove those 2 triangles are congruent? Which of your 5 are you going to use? HL theorem. Okay, if you're going to use the HL theorem, you have to meet 3 conditions. What are those 3 conditions? We need a right triangle. We need a congruent hypotenuse and a congruent. Do we have any of it listed yet? Which one? Good. The given gives us the hypotenuse. So we still need to list in there that we have congruent legs and that the triangles are right triangles. Which one do you want to do first? Okay. CB is congruent to BE. And how did we know those 2 segments were congruent? Definition of a bisector. There are your legs. So we got the H and the L part of the HL theorem. Now we have to decide or state in there that they're right triangles. How did we know that the triangles were right triangles? How did we know they were right angles? Because of the perpendicular lines. Good. So angle ABE and angle DBC are right angles by the definition of perpendicular lines. Therefore, triangle ABE and triangle DBC are right triangles by the definition of a right triangle. Oops. I didn't mean to strike through it, I meant to highlight it. So we got the right angles because of the perpendicular lines. Then I can say I have right triangles because of the right angles. No, you have to tell me now that the triangles are congruent. So triangle CBD is congruent to triangle EBA by the HL theorem. The one that's most commonly forgotten is telling me that they're right triangles. You'll remember the H and the L because it's in the theorem, but you got to remember that you have to have right triangles then too. Two examples left. Number 3, circle the two triangles that are congruent by the HL theorem. There's 3 triangles there. Circle the 2 that would match up with the HL theorem. And think about what H means and what the L means in that abbreviation. What's the H stand for? The hypotenuse. So if you're going to try and prove that triangles are congruent with the HL theorem, you have to have congruent hypotenuses. I don't know how to pluralize these. So you have 3 triangles there. They're all right triangles. Do any of them have congruent hypotenuse? Which ones? The first 2. Remember, across from the right angle is the hypotenuse. So LN is a hypotenuse. OP is a hypotenuse, and so is RT. When I highlight them, you can see that these both are 5, so they have congruent hypotenuse. Then you got to double check the legs. Here's a leg, here's a leg. Are they congruent? Yeah, because they're both a length of 3. So these 2 are congruent by the HL theorem. Let's practice a congruency statement here. Triangle LMN would be congruent to which triangle? Good, OQP. You have to make sure those statements are in order, otherwise it doesn't make any sense, right? Yeah, okay. Last one. You might want to write kind of small, because I didn't leave you very much room. What? All right, so this one says, for what values of x and y are the triangles congruent by the HL theorem? HL theorem, what does H stand for? Hypotenuse. Which expression on that first triangle is representing the hypotenuse? Good. So it should be congruent to which segment in the second triangle? Y plus 4, because you need to have congruent hypotenuses. That's what the H stands for. What does it mean if 2 things are congruent? They're equal. So set those expressions equal to each other. 4y plus x equals y plus 4. I'm going to combine like terms and subtract y over. And I get 3y plus x equals 4. Yeah, because I only have one equation with an x and a y. If I have 2 unknowns, 2 variables, I need to come up with how many equations? 2. I need to come up with a different equation here then. I didn't hear what you said. You had a marker in your mouth. That's okay. All right. Six. Good. Those two have to be congruent because it says use the HL theorem. The L stands for legs. So my legs also have to be congruent. So I can set the other expressions equal. So then I get y minus x equals x plus 6. What should I do? How? Add x to the right. So then y equals 2x plus 6. Excellent. Two equations with two unknowns, an x and a y. There's two ways to solve this. We've done substitution. You can also do elimination. We haven't really done much of that. Since y equals 2x plus 6, we can substitute 2x plus 6 in for the other y. You got to plug it into the other equation. Then this becomes 3 times the quantity, 2x plus 6, plus x equals 4. Taking 2x plus 6 and replacing that with y since they're equal. What do I do with my 3 out front? Distribute 6x plus 18 plus x equals 4 then. Combine like terms. What's 6x plus x? Subtract 18 to the right. What's 4 minus 18? Negative 14. How do I get rid of the 7? X is equal to negative 2. It says find the values of x and y. Yeah, plug negative 2 in. I can plug it in over here where I have it circled in blue. Y equals 2 times negative 2 plus 6. Well, what's 2 times negative 2? Negative 4 plus 6. 2. Let's double check. X is negative 2 and y is positive 2. X is negative 2 and y is positive 2. So when I plug that in, I get 4 times 2 minus 2. What's that give me? 6, all right. Y is positive 2, x is negative 2. When I plug it in over here, it becomes 2 minus negative 2. That's 4, okay? Plug it in over here, 2 plus 4 is, and negative 2 plus 6 is, all right, your legs are the same length, and the hypotenuses are the same length. So our x and y values are correct. Questions? All right. Just a second.